Look at the current crop of artificial intelligence. We have moved past simple chatbots answering trivia questions. Today's AI agents are actively executing tasks, booking flights, routing customer service tickets, and writing code in real time. But as these agents take on more responsibility, a major limitation becomes obvious. They suffer from what engineers call the goldfish problem. By default, a generative model has no persistent memory. It will process a 10-step workflow and 5 minutes later, completely forget the user's context or the actions it just took. Add to that the toddler problem. We are deploying autonomous agents into complex business environments without giving them procedural boundaries. Without strict management, an agent does not know which database is safe to query and which one it might accidentally overwrite or delete. To give these systems structure, developers are converging on two specific infrastructure frameworks. The first is ADK, the Agent Development Kit. The second is MCP, the Model Context Protocol. Search for these terms online, and you will see endless debates about which one to choose. But that debate misses the mark entirely. You do not choose between them because they solve two completely different problems. A reliable digital workforce requires both an inner cognitive structure to orchestrate logic and standardized outer connections to interact with the real world. Think of them as the brain and the hands of your system. The Agent Development Kit, or ADK, operates as the brain. It is an operating system that forces inherently unpredictable language models to behave like structured, testable software. ADK introduces a dedicated memory manager. This gives the agent a short-term working state to track ongoing tasks in a single session, alongside a long-term memory to recall user preferences and past interactions across weeks or months. It also provides an orchestrator or scheduler. Instead of letting the model guess what to do next, the scheduler routes incoming tasks, applies rigid governance rules, and defines the exact sequential logic the agent must follow. This orchestration builds multi-agent hierarchies. A single high-level manager agent receives a complex prompt and delegates specific tasks to specialized sub-agents below. By dividing work, the system avoids context dilution. Each sub-agent receives only the precise slice of data it needs to execute its job. With its memory management, strict scheduling, and delegation capabilities, ADK provides the internal cognitive structure required to plan and remember tasks reliably. The brain is organized. Now it needs to interact with the world. Historically, giving an agent access to external data meant writing custom, brittle API integrations for every single tool. Every database, file system, and cloud service required its own bespoke connection logic. That brings us to the Model Context Protocol.
MCP acts as the hands of the system. It is a universal, model-agnostic standard designed entirely for tool and resource access. MCP replaces custom codes with standardized servers acting as identical wrappers around external tools. Whether accessing an SQL database or local file system, the interface looks identical. Servers expose specific tool schemas to the agent's context window only when a task requires them. Crucially, MCP manages the security of these interactions. It handles the authentication tokens automatically and runs the tools in isolated sandboxes. This prevents an agent from escalating its own privileges or executing destructive actions on your live systems. ADK plans the workflow, but MCP provides the secure, standardized pathways to execute those decisions across actual enterprise infrastructure. However, even with organized logic and standardized connections, there is a final hurdle. In highly regulated industries like healthcare and finance, organizations hesitate to deploy these agents because connecting to external APIs creates a risk of data exfiltration at the last mile. To close this trust gap, enterprises must have physical ownership of their model weights and infrastructure. They require sovereign AI. This is where Treecapital AI's Anven ecosystem enters the picture. Anven is a private, on-premise cognitive layer designed to completely encapsulate ADK and MCP workflows behind an enterprise firewall. Anven prevents sensitive telemetry from leaking by operating entirely offline or within air-gapped virtual private clouds. The data never leaves the organization's perimeter. For hardware outside the main server room, Anven provides edge-native capabilities. As shown in this schematic, 3 billion parameter models transition directly from large servers to mobile phones and embedded microchips, without relying on a cloud network. This edge quantization drastically reduces memory overhead, allowing highly sensitive corporate data to be parsed locally on a user's device. By encapsulating the cognitive orchestration of ADK and the standardized connectivity of MCP within the sovereign fortress of Anven, global industries now have a secure blueprint to deploy an autonomous digital workforce.